Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. So today we continue our lesson on introductions to scientific programming. So today we are learning about chapter 6, which is related to the control input and output. So without further ado, let's continue. So this is the today objective, okay? So the first objective is to prompt the user for input to an M file program. So at the end of this lesson, you will be able to create a program where the users need to give an input in order for your program to run. Okay, for example, please enter your age, please enter your gender, or so on. Okay, so at the end of this chapter, you will be able to do that. Okay, so the second objective is to display the output by using the DISP function, display functions. Okay, so at the end of today's lesson, you will also be able to display your output by using the DISP function. Okay, your third objective is to create a formatted output by using the Fprintf and also Sprintf. So in this lesson, you will know how to display your output by using Fprintf and also Sprintf. And what are the differences between Fprintf and also Sprintf. Okay. In 4, 5, and 6 objective, you will not learning in today's lesson, but you will learn this lesson in your next class. Okay. So actually the fourth objective for this chapter is to import and export ASCII and binary files by using load and save functions. The fifth objective is to import and export spreadsheet files using XLS reads and XLS write functions. So the fifth objective is basically all about importing and exporting the Excel file. Okay, and the sixth objective is know how to perform the debugging. All right. So let's continue to our lesson. Okay. So before you proceed on today's lesson, let us recap the below diagram, which is from chapter 2, and generalize it as a system. Okay, as you all knows, okay, in the last chapters that we are learning, okay, previously we are learning about variables, okay, how to initialize a variables based on its data type, and how to initialize its size, and how to initialize its value inside the variables. And then we are learning about operation. So what we are doing with those variables, okay? The first thing is we need to do some statement. So it means that it is all about assignment, decision. So decision, it is related to the if-else situation or if-else function, and also switch. Okay, switch statement. Okay, we are manipulating our input. Okay, the next part is the repetition. So repetition is all about the loop, the for loop and also the while loop. Okay, so those are the operation that you did with your variables. Okay, for the last chapters, we are learning about functions. Okay, function is actually a group of statements that perform a task. Okay, inside a function, there are several part of the decision, which is if else, and also several while loop or for loop. Okay, so you group it together and it will become a functions. And also last chapter, you also learn about command. So command is actually like a syntax that you create, and it doesn't give any output, but it changes the MATLAB environment. For example, you are typing clear all inside MATLAB and it will clear all of the variables. So those things, we are calling it as command. Okay, so basically what you are doing in the past chapter is you are creating or designing the program inside the MATLAB. Okay, as you all know, to create a program you have three options. You can have a function files, you can design it in terms of script files, and also you can design it by using the command window. Okay, but all of the program that you created must have an input and must have an output, or must have multiple input and output. Okay, so it depends on your program. Okay, but this chapter you will learn how to control those kind of input and how to display those kind of outputs from your program. Okay, so let us proceed to what we are actually learning in this chapter. Okay, so the first part of this lesson is how to initialize and how to recognize what types of input and output data that we have. Okay, so the first type of data is the prompt data. So what is actually prompt data? So prompt data is actually created or displayed at command window. And we can also create prompt data when running a script function. Okay, so data is temporary, so it will be gone when certain function, example clear or operation, is called, or when MATLAB is closed. And it is useful as a quick test input or output data or small size data. Okay, so basically a prompt data is like it's just like a temporary data. Okay, so the data is temporary, so it means that when you are requesting an input to the user, for example, please enter your age, and then the user enter the age of 16, and then after you close the MATLAB, so those data will be gone. Okay, so this kind of prompt data, it is very useful for quick test input or output data. Okay, but the data will lost when you close the data or when you create clear all. Okay, so if your program is designed to store the data, you are not recommended to use the prompt data types. Okay, you need to use the other types. Okay, all right. So the second type of data is import and export data. So for import and export data, actually the data is stored in a file, for example .matrix, .dat, .txt, .xlsx, and so on. Okay, so for this type of data, the data is permanent as long as the file exists. So when you close the MATLAB or when you type clear all, so those data will still remains. Okay, because you store the data inside the separate file. You are not storing the data inside the MATLAB workspace. Okay, so import data is normally a big size data and more realistic and practical data. So basically, when you are storing a data, it is basically a data which has a large size of data. Okay, so export data can be used for future usage or for other referencing. Okay, for example, when you are creating a prompt data, you can also save those prompt data inside a file. Okay, when you save those data, it will automatically become import and export data. Okay, because when, for example, let me show you, this is MATLAB. All right, so now I will initialize one variable called a. Okay, a equals to 5. So when we initialize a variable inside MATLAB, it will be automatically become a prompt data, where the data is shown inside the workspace. Okay, but when we want to validate whether it is a prompt data, you can just clear all. Okay, clear all, and then the data has been lost and you don't know where you want to load back the data. So those kind of data is called the prompt data. Okay, but when we initialize a variable inside MATLAB, for example, I initialize back the variable a equals to 5. Okay, but this time I save the data inside MATLAB. Okay, to save the data inside MATLAB, you can just create the command save. Okay, and the variable that you wanted to save. Okay, if I want to save a, I put the command save in bracket, and also you need to have the apostrophe here, and then you put your variable name a here. Okay, and then it will save the variable a. All right, so this time it has become the import and export data, where when you clear all, okay, when you put the clear all data, it will lost, right? But you can call back the data inside a by using the command load. Okay, and then you put a, sorry, load, you need to put like the apostrophe here. Okay, so it will load back the value of a inside the workspace. So it means that a right now has become the import and export data. All right, okay. Okay, so next is the prompt input and output data. So right now you will learn in detail how you want to prompt the input and output data inside MATLAB. Okay, so first we are learning about prompt input. So prompt input is actually we are requesting an input from the user. Okay, but how we does it? Okay, first, when running a script or function, okay, function input can be used to request a user input data at the command window. Okay, and the syntax that we are using in order to request the input from the user as follows. Okay, you can choose one of the two syntax here. Either x equals to input and then the message that you want it to display towards your user, and also you can use string equals to input and the message that you want it to display, and also the s here. So later on I will show you some example on how you want it to implement the requesting input command for the users. Okay, so the description is, okay, so displays the text in message and waits for the user to input a value and press the return key. Okay, and the second description is user can enter any types of variables, expression like pi over 4 or random tree, and can also use existing variables inside workspace. So the data that the users can input inside your function, it is any types of variables. Okay, so when s is used as the second input to the function, it returns the input as a string. Okay, so whatever the input that has been given by the users, it will be converted into string when this type of command is being used to request an input from the users. Okay, all right, so let's take a look at the first example. Okay, all right, so this example, it is used to calculate the area of a rectangle. Okay, where the area equals to 0.5 multiplied by width and multiplied by height. But where does we get the value of width and the value of height? Okay, this time we are getting those data, width and height data, from the users. Okay, how to do that is you need to use this kind of syntax. Okay, so in order for you to request an input from the user, you need to put, this is the variable name that you wanted to store the height data. Okay, height equals to input, you need to use input syntax, and then inside the input syntax you have a bracket and you have apostrophe here. Okay, and then this is the message that you want the user to know. Okay, what kind of data that they wanted to insert. Okay, so you just put it into height. Okay, and then the user will put in the data. Okay, the MATLAB will hold this command until the user inserting the data. Okay, and then after the user is inserting the data, it will go to the second line of the coding, which is requesting the width data. Okay, and then the width data that has been entered from the user will be saved inside the width variable, and then it will calculate the area, and then you will get the area. Okay, so let me copy this coding and show it to you. Okay, all right, let me copy first. All right, this is the MATLAB. Okay, so let me clear CLC. All right, so when we are running this coding, okay, it will ask you to enter the height. Okay, so if the user doesn't enter any value for the height, it will not proceed to the next line of coding, which is enter width. Okay, so for example, if I am entering the value of 10, all right, and then it will proceed to the second line of the coding, which is to enter the width of the shape. Okay, for example, for the width I give 5, and then it will give the output of area by calculating the area by using this formula. Okay, so it will give the output of area equals to 25. Okay, so this is how you wanted to request an input from the user. Okay, by using an input function. Okay, basically input your message, and after that the user will enter whatever the input. Okay, and then it will go to the second line of coding, and then it will go to the next coding line, and it will finish because your coding has been finished in the third line. All right, okay, so next is prompt output. So how exactly you wanted to display the output to the users? Okay, so there are several methods of displaying the output to the users. Okay, all right, so first method is, I'm sure that all of you already done this, right? First is enter the name of the variable without a semicolon. Okay, and you will have both variable name and its value are displayed. Okay, for example, we go back to the MATLAB. Okay, this is MATLAB. So you see here we have right now we have the variable a equals to 5. So basically, if we wanted to display the value, okay, we just put a without any semicolon, and it will give a equals to 5. Alright, so that is one of the methods on displaying the output. Okay, so the second method is by using DISP function. Okay, so DISP function, which is actually a notation about display, it will display only the values of a variable without the variable's name. Okay, so for example in MATLAB, okay, right now we go back to our example, which is a equals to 5. Okay, so if we are using a display, okay, if we are using display functions, we put DISP and then in the bracket what is the variable that we wanted it to display, and then it will display the value inside variable a. Okay, it will not give the output of a equals to 5, but it just gives the value inside variable a. Okay, alright, so the third methods of displaying output is Fprintf function. Okay, so Fprintf function, it will display the values of the variable with formatted string and return the size of the variable. Okay, for Fprintf, it will display the value of the variable with its own formatted string. For example, if you wanted to display 2 decimal places, 3 decimal places, and so on, it will return based on your control variable. Okay, if you wanted to initialize this as decimal places of 2, so you can initialize it like that. Okay, but it will return the value according to the size of the variable. Okay, for example, if our variable is a double, so it will return it as a double. Okay, so later on I will show you some of the example of Fprintf function, because there are several types of methods that we can use in order for us to use the Fprintf function. Okay, the next method is Sprintf function. Okay, so this function holds the values of the variable with formatted string, and it returns the value of the variable. So note that sprint does not print anything on the command window. Okay, so for Sprintf function, the difference between Fprintf and Sprintf is Fprintf will return the size of the variable, which is, for example, if you are initializing the number, it will return in double or integers or whatever the number format that we already initialized. Okay, but Sprintf function, it will return the data in terms of string. Okay, so at the end of today's lesson, I will show you in clear what are the differences of Fprintf and Sprintf. Okay, all right. So let's take a look at the DISP function first, display functions. Okay, so the DISP function can be used to display the contents of a metric without printing the metric name. Okay, it accepts a single variable as input. Okay, all right, so for this example, okay, so let's take a look at example number 2. Okay, for this example, you see here, we already initialized x as the value of 1, 2, and 3. Okay, and then when we display the value of x, it will only display the value inside the variable x. Okay, without indicate that x equals to 1, 2, 3. Okay, so entering x without semicolon will display both the variable name and its value. So I already shown to you before. Okay, and this function will display the variable values only. Okay, however, the DISP function will only display the value inside variable x. So I already showed it to you before. Okay, all right, so next is Fprintf function. So how we wanted to use this function in order for us to prompt the output inside MATLAB. So Fprintf offers more formatted output display. Okay, why we are using this? We can have a more control over your output than the DISP function. So it means that we will be able to control what types of output and how many outputs that we wanted our output in MATLAB to show. Okay, for example, 2 decimal places, 3 decimal places, 4 decimal places, or only integers. So you can control that by using Fprintf. Okay, and for Fprintf, you can also combine the text and numbers in the same output. Okay, and also you can control how many digits to display and their position. So I already mentioned you some of the example before. Okay, Alright, so the syntax for Fprintf function is Fprintf formatted strings A1 until AN. So A1 until AN is actually the variables that you are shown. Okay. So the description of the syntax is the formatted string is the displayed string with a formatted values of A1 to AN. Okay. Okay, so basically inside the formatted string, you can combine the tags, you can combine numbers. Okay, so it will show everything inside the formatted string. Okay, so A1 to AN are the variables to be displayed. Okay, and symbol percentage is used as the placeholder for the variables, and the formatting information of the variable is written after the placeholder symbol. Alright, so in Fprintf, as I mentioned before, it can combine text and also number all together. Okay, but if we wanted to insert a specific value of the variable, you need to put a percentage before that number. Okay, so I will show you some of the example. Okay, so before we proceed to the example, let me show you the formatting operator of Fprintf. Okay, so the table below shows some of the commonly used conversions operator. Okay, see my lab documentation for the full list of the formatting operators. So in order for you to see the full list, you can go to the MATLAB documentations. Okay, so the conversion operator is compulsory while the others are optional. Okay, so in order for you to initialize the value inside Fprintf and Sprintf, you need to use the conversion operator. Okay, so first is, this is the placeholder, which is the percentage that you need to do. Okay, so the conversion operator is the last one. Okay, the F1. Okay, so the F1 is related to here. Okay, so if you wanted to display only integers, assigned integers, you can put it %d or %i. Okay, for unsigned, you need to put %u. For floating point, you need to put %f. For string, %s, and also for exponential, you can put it like %e. Okay, so inside the formatting operator, it has some other elements. For example, you have identifier here, you have flags here, you have fill with here, and you have a precision. Okay, sometimes the flags is actually when you are, okay, let me show you this example first. Okay, so this is one of the example where the value of 123.45678 has been initialized. Okay, so when you wanted to display inside the Fprintf, for example, okay, for example, if you are displaying percentage, okay, this is the format operator example, percentage 09.3f. okay, so let's go, percentage is the placeholder. Okay, so placeholder is needed where, because it is where you are putting the number, okay, that are referring to specific variables. Okay, percentage is compulsory and f is also compulsory, but because this time you are initializing a floating number, you will put f here. Okay, and then 3 here, it will indicate the decimal place of your number. Okay, because 0.3 here, it will become 0.457 because it has 3 decimal places. So right now you already control what kind of input that you wanted to display. Okay, so actually 9 here is, we call it a fill width. So fill width is actually the number of elements that has been displayed, that will be displayed inside your output. Okay, for example, here, this is the output that has been produced. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has 9 fill width. Okay, because it has a total of 9 element here. Okay, and then 0 here indicates, okay, because this number, if we are initializing this number as 3 decimal places, it only has 1, 2, 3, 4, 5, 6. It has only 6 fill width, but we initialize it as 9 size of fill width. So it will fill up the other 3 with the number of 0. Okay, so it will become 0, 0, 1, 2, 3, 4, 5, 7. Okay, what do you call here, dot here. Okay, decimal places here is also counted as one of the fill. Okay, So it will become 00123.457. All right. Okay. So let's take a look at some of the example of Fprintf with single value. Okay. So this is example number 3. All right. So first, in this example, we are initializing the variable cows, which stores the value of 5. Okay. And then we are using fprintf, okay, and then the bracket, and then we need to have an annotation or apostrophe here, okay. So this is the placeholder, okay, where you wanted to show the value of cows, okay. So you need to put a percentage here, okay, as a placeholder, and then 1, which is the field width, okay, dot 2, which is 2 decimal places, and f is in the types of the floating numbers, okay, and then cows in the pasture, okay. So actually the value of 1 here, it doesn't matter what you put here, okay, it will display the value of correct integers, okay. So if you put 2.2f, it will still displaying a 5.00, 3.2f is still, you know, displaying the type of 500, okay, and it will display the value of 2 decimal places here because we are initializing dot 2. So it means that dot 2 decimal places of floating numbers. Okay. So the string, which is the first argument inside the fprintf function, contains a placeholder, okay, where the value of the variable, in this case cow, will be inserted. So if you wanted to put the value of cows, you need to put the percentage and then the types of output. Okay. The placeholder also contains formatting informations. So in this example, the %1.2f tells MATLAB to display the value of cows as 1.2 fixed point format, 1 digit before decimal point and 2 digit after the decimal point. So let me show you. Okay, let me go to the example. Okay, so let me show you the MATLAB. Okay, what will happen if we are changing the value. What will happen if we are changing the value inside MATLAB? Okay, right. So let me clear first. Okay, let me paste. Okay, all right. So you see here we are initializing the value of cow equals to 5. Okay, when we run it, it will says that there are 5.00 cows in the pasture. Okay, but when we are changing the number of decimal places, for example, we put here 1.4f. So it means that a floating number with 4 decimal places. So it will become, there are 5.0000. So it will become 4 decimal places. Okay. But what if we change it into 8 field width? Okay. What will happen? What will happen here is that it will automatically put some space inside the number here. Okay. This space here will indicate the field number of 8. Okay, actually there are two more field. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it will put some space here. So this space indicates a field operator which is not enough. Okay, because we only have 1, 2, 3, 4, 5, 6. We only have 6 elements here, but we initializing 8 as the field width. Okay, so it will fill in 2 more elements by using space. Okay, but you can also fill in the the remaining field by using 0. So you can just put 0 here. So it is actually like a flag. Okay, you run it again, it will fill in the remaining field width with zeros. Okay, so you will have, because we are initializing 8 field width here, so you will have 1, 2, 3, 4, 5, 6, 7, 8. Okay, you will have a total of 8 field width, and the remaining field will be filled with the value of 0, and you have 4 decimal places. Okay, all right. Okay, so next is, what if we wanted to use fprintf but with multiple values? So what should we do? So let's take a look at example number 4. Okay, so for example number 4, we have a variable L with a total of 1, 2, 3, and 4. Four different variables, okay? All right, but here you see here, okay, so this is the first row and this is the second row, okay? So Fprintf, okay, percentage, the field width is 2, dot decimal place is 2. F, which is the floating number, M, which is the meter, okay, which is the meter, is equivalent to percentage 5, which is the 5 number of total field width. D is the integer, okay, and then mm over n, millimeter over millimeter, it's not over mm, and slash n is actually the new line, which is the special character inside the MATLAB, okay, and then it will print the value of L, okay. So in this example, there are 6 values from, there are actually 4 values from matrix L, okay, but there are only 2 placeholder, okay. But in this case, Fprintf will repeat the string. Okay, let me correct the slide first, okay. Okay, let me go to okay, there are actually 4 values, okay. All right, let's take a look at example number 4 again. Okay, so in this example, there are actually 4 values from matrix L, but there are only 2 placeholders because we only have 2% here, okay. So in this case, Fprintf will repeat the string only until the last values, okay. So the sequence of the placeholder is as follows, okay. So the first placeholder, it will display the first and the third values, elements, okay, while the second placeholder, it will display the second and fourth values of the elements. So previously you already learning about linear indexing, right? So it will follow the linear indexing. All right, and also you see here slash n is called the special character for new line, okay. So if you wanted to initialize a new line inside Fprintf, you need to put slash n at the end of the message or at the end of the output. All right, okay. So next, let's take a look at some of the special character inside MATLAB. Okay, so special characters are characters that you cannot enter as ordinary text, okay. So for MATLAB, there are some of the special characters that you need to remember, okay. Alright, so below table shows how to represent the special character in the Fprintf functions. Okay, so if you wanted to see the full list, you can just refer to the MATLAB documentations, okay. For example, if you wanted to initialize special quotation mark, you need to put double quotation here. Okay, if you wanted to initialize the percent character, you need to put double percentage for you to not for MATLAB to not be confused with the placeholder, okay. And then for backslash, you need to put it this. For new line, you need to put slash n, and so on, okay. Alright, but the character whose Unicode numeric value can be represented by the hexadecimal number. Okay, there are some special character, for example, Greek characters, that you need to put it inside the hexadecimal numbers. So for those documentation, you can refer to the MATLAB. Okay, so now let's take a look at some of the example of prompt the output by using the special character. Okay, so the first one is the Greek letters. Okay, let's take a look at example number 6. Okay, so in this example, we wanted to show a table of omega and a table of sine omega. Okay, so first we initializing some values of omega first. Omega equals to 0, pi over 2, pi, and also 3 multiplied by pi over 2. Okay, and then s equals to sine omega, which is displayed here. Okay, so as omega is like a special character, so we initialize omega, which is the variable omega, as this is the the apostrophe here, and then we have the slash here, slash x, which indicates the hexadecimal 3C9. Okay, so you need to initialize this hexadecimal number in order for you to get the symbol of omega. Okay, so this is the symbol of omega. Alright, and then you need to put Fprintf, okay, omega, which is the symbol of omega here, because you already initialized the hexadecimal value of omega here, okay. And then you put your your string here, and then sign, and then you put your omega here, and then you put the /n because you wanted your next coding in order for you to goes to the next line, okay. So you need to put /n here. All right, and then you put fprintf again, and this is the placeholder here, okay. And then you need to /x3c0, so it will initialize some of the letters, okay, which is pi. All right, and you have a next placeholder here, and then this is the floating numbers with 3 decimal places, and then you have /n here, which is initializing a new line. And then you can see here that we have two different placeholders. So the first placeholder will be referring to omega over pi, and the second placeholder here will be referring to variable s, which is referring to here, okay. All right, so since scientific formula normally use Greek letter, using MATLAB special character will enable user to properly display the Greek letters, okay. So because this subject is all about scientific programming, and scientific programming is all about the equations, okay, all about the some of the symbols, okay. So in order for us to initialize those kind of symbol, you need to use Greek letters, okay. Therefore, MATLAB has already initialized some of the Greek letters, but you need to initialize it inside the hexadecimal number, okay. So you need to refer to the MATLAB documentation for that. All right, so 3C9 and 3C0 are the hexadecimal Unicode for omega and pi respectively. All right, so for example, when we are running this coding, so I will show you, okay. All right, let me copy the coding first, okay, and then let me paste inside the MATLAB, okay. All right, so I will clear it first, okay. So when we run this coding, okay, it will says that omega equals to 0.0 pi, 0.5 pi, 1.0 pi, and 1.5 pi. So as the first floating number you see here, we are initializing a variable with 1 decimal place, so it will become 1 decimal place, okay. And then x3c0 will be referring to the pi, okay. Omega here, which is referring to the x3c9, will be referring to the symbol omega here, okay. So this is how you can initialize and you can display the special character, which is the Greek character in this example, inside MATLAB. All right, so you need to refer to the MATLAB documentation, okay. But I think there are some errors here, okay. It must have only 1 decimal place because we initialize it 1 decimal place, okay. And then it must have a pi here, okay. Let me pi here in each of the output here, because when we run inside MATLAB, it has pi, and pi. All right, okay. So next is the Unicode. So Unicode is a part of the special character inside MATLAB when we are displaying the output, okay. So below are the Unicode hex values for some commonly used Greek letters and math symbol that cannot be entered directly from your keyboard, okay. So you can see here there are some of the hexadecimal codes that you need to not remember, but you just need to understand how to initialize it, okay. If you want to remember, it's quite impossible because it is quite a lot, right? Okay, so these codes, okay, you just need to know how to use it. The example is already shows inside the example number 6. All right, so this is some of the characters that you can insert inside MATLAB. All right, okay. So next, let's take a look at the Sprintf function. Okay, so how we wanted to initialize Sprintf and why we are using Sprintf. Okay, so the Sprintf function is actually similar to the Fprintf. So instead of just sending the output to the command window, Sprintf can return the displayed output string as a variable. Okay, so as I mentioned before, the difference between Sprintf and Fprintf is Sprintf will return a value as a string, but Fprintf will return the value as the any numbers type, for example, integer, floating number. So it is all depends on the format operator that you used earlier. Okay. So why we are using the Sprintf? So Sprintf, it is used to create a sequential file name when there are a number of files to be created at once. So the second application is in terms of dynamic cell range referencing when importing or exporting data from or to the spreadsheet files, and also for graph annotation. So this will be discussed in the next chapter. All right. Okay. So Sprintf return variable. So now we will take a look what is actually a return variable and how it differs from Sprintf and Fprintf. Okay, so let's take a look at example number 7. Okay, so for example number 7, you see here we have two variables, okay, which we wanted to return. So f equals to Fprintf, okay, some output, and it will return, and this is the variable that we wanted to display, which is 4. It has 4 total of field width with 2 decimal places, and it is type of floating number, which is double. Okay, and then it will display some output is 24. All right, and then we initialize one other variable, which is variable s, but this time we are using Sprintf. Okay, so we are using the similar type of type of a comment, okay, type of message, and it also displaying the similar output. Okay, so 4.2f, which is a floating number with 2 decimal places and with 4 field width. Okay, and then it will display the similar output because the output is the number is random. Okay, that's why it showed the different number of output. Okay, and then when we are typing the whos, okay, so this is where we wanted to see what types of value that has been written by Fprintf and also Sprintf. Okay, you see here the variable f, which is referring to Fprintf, it will return the value of a double type, which is directly referring to the variable that we actually wanted to show, okay, which is a variable with the type of double. Okay, but for Sprintf, which is referring to the variable s, okay, it will store the data type of character. Okay, so which is it will store this value, some output is these numbers, okay, and /n. So it will store all of this string. Okay, so it will store in terms of characters. Okay, so this is the main difference between the Fprintf and Sprintf, where Fprintf will store the value of the variable that we wanted to display, which is pi multiplied by 1000. Okay, but the value of but Sprintf will display all of the string here. Okay, alright, so in this example it shows that the return variable for Fprintf equals to the size of the displayed string, so it will be referred to the size of pi multiplied by 1000, but Sprintf will be stored the value of actual displayed string, so it will store this value. Some output is 3.141.59. Okay, guys, I think I noticed some mistake inside the slide again. Okay, so actually this one is similar here, 3.141.59. I don't know why there is a mistake. Okay, maybe there are some mistake inside the slides. All right, so let me go to the slide again. Okay, so as a conclusion, the main difference between Fprintf and Sprintf is the type of the return variable, where it will return as the integer or a number, but this one it will be written in terms of the full string of the output. All right. Okay, so this is one of the program that is fun to try. Okay, so this MATLAB program use input, display, and Fprintf, so you can do it by yourself and see how the outputs look like. Okay, so you can try it by yourself. Okay, so I will give later on the slide to you and you can try to change some of the characteristic here. Okay, or you can also change the message here. Okay, so it depends on you, so you can just try and you can learn from this program. All right, so for the next class you will learn about how to import and export data and how to do debugging. Okay, So we will meet again in next class, which is on Sunday. And I think that's all for today's class, and thank you. Okay, so if you have any questions, you can just WhatsApp me, and I think that's all for today's class. Thank you.